All right, so welcome back, everybody. We're in week 3 now. So just a reminder, today we'll be doing more abstracted body stuff. So we'll pick up where we left off last week, which was in P5. I got us a skeleton model set up so we can go through that. I also want to cover how to convert your video from P5 into an actual video, because P5 is not really well set up to record video. So I'll show us like a quick little demo on how to do that. We'll also look at FFmpeg to create video. For those of you who are not used to FFmpeg, it can be a little daunting at first, but once we get the code, like you'll just copy and paste the code and sort of learn to change one or two things on it, and I'll walk us through that. And then you'll pretty much see it probably every week, because it's just gonna be a common thing we do in class. So you'll get used to it by the end of this class. You'll have memorized, maybe. I still haven't memorized it. There's like some weird stuff in there that I just always copy and paste. And that's totally fine. So we'll go over that, and then the second half of the class, or maybe, I don't know, depending on whenever we decide we're done with P5, we'll look at how to do some actual body segmentation. So we'll look at how to use a machine learning model called BodyPix to actually get parts of the body. And we'll see that it is not as good as you might expect, but it's kind of fun to play with. So we'll start there and we'll see what we can make out of it. And lastly, I just want to remind everyone, like, for the next, every week during our tutorials or demo sessions, like, the point is these are pretty lightweight demos just to sort of show you what's possible. And then I would love, like, obviously depending on what time you have available to you throughout the week, maybe in a couple weeks start to think about like a single project maybe you may want to work on. And I'm happy to help take you through all of that. So like, come with an idea and then we can talk about how to do it. If you are not a person that has written a lot of code before, I'm happy to help with that as long as you don't mind me open sourcing those tools. So I'm here to like work with y'all. So it's not required that anyone makes a project out of this. I just find that you have more fun or you feel more accomplished when you actually finish a project out, right? Like, you can sit here and watch these videos and then like when class is over, you're like, okay, cool, I guess I learned something, but I didn't really make anything. And you learn a lot by just making it. So I would definitely encourage you that if you have the time to think about it. And again, remember that at the very end of class, we'll do a show and tell. And if all you did was run the demos, that's totally fine. Show us what a demo looks like on whatever video you used. That's totally fine to do. But if you do have a more elaborate project or just something a little bit more that you wanted to show, I think those are great opportunities to show a little bit about how you take, maybe your own artistic interests and bring that into some of these topics. So I also know that I think maybe Nauko or someone else mentioned, like, I have an idea based on a video that we watched in class, but I don't know how to use machine learning in it. And like, we can talk about that, but if you make something cool and it didn't require machine learning, that is also cool. Part of what I want to do with this class is just inspire everyone. And if you're like, I learned about the machine learning stuff, but I really want to make something using the tool set I have, that's totally cool. And I would encourage you to. So, this class is more or less like you've paid a fair amount to like have access to me for the next 10 weeks or whatever. So I would definitely encourage you to use that. And I'm happy to help where I can. Any questions about any of that? All right, cool. So let's dive into P5. So I know a couple of you have already started playing with different things. Like I know Steve was working on how to replace the dots that we had drawn in the first half with like images. I have heard from a couple of you that you want to either explore doing multiple people in a pose detection or other things. So we probably won't cover all of that today, but we can at least look through and sort of dig through what's available. And again, those are great. If you have an idea for something and you don't know how to implement it, like, please drop a note either in the Slack or to me directly, and maybe we can work out how to like build some of that stuff. All right, so I'm going to share my screen, and we'll jump into P5. So I'm going to show one or two things, and we might just bounce around a little bit. So first off, I want to show just the skeleton model that I built for us this week. So let me find it really quickly here. And let me pop this URL into the chat for everybody. And again, if you're not logged into P5, you probably want to, just so you can duplicate these and make copies for yourself. Running slow today on the computer. Let's see. All right, so this is the first sketch. This is the skeleton sketch. So as we talked about, like, you know, those dots we looked at last week only give us, you know, the positions or the coordinates of where the model has determined a key point is. But to actually create a skeleton from that, you have to do a little bit more, right? You have to be able to say, connect the knee bone to the, you know, ankle bone or whatever, like whatever that rhyme is. You know, you actually have to put the parts together. And I had shown previously an image that gave the number values. And I think Ben, who I don't think is here yet, but Ben was saying that it didn't match up for him, and he was absolutely right. The reason for that is the model they expect us to run is called the 25, and that uses the key point system that I showed in class last week. The model we are using, which is 25B, which is more accurate, apparently also uses a pretty much undocumented different structure for those things. So I spent some time this week going in and figuring out what the actual order of those points is, so we could actually like build a skeleton from this. So let me just play this and you can sort of see what happens. So we'll hit play. Why isn't this animating? I think because, yep, here we go. So I have a debug in here. So let me remove this. So if you have the code open, just comment out line 29 or just delete it. And we want to then comment in the draw function. So we're gonna, sorry, I'll save this out and I'll download it for everyone when class ends. But we're gonna bring line 31 through 33 back in. So just delete those double slashes in front of there. And now we can run this and it should animate. There we go. Okay, so a couple of things you're seeing here. The first is that we've got this background, so we're creating sort of that light trail through it. So if you want to change that, because I think a couple people mentioned they were getting the light trail stuff and they didn't really want that in there. So line 31 sets a background, and it sets a background of black. This is RGB plus alpha, and this is where we get our transparency. So if I hit stop here, and I change this to a value of 1 instead of 0.1, and hit play. You'll see that now we don't get any of the background of the previous trails. So line 31 handles that. So next you'll see that we do have these colored dots. That's in this thing called draw pose, which was the same function we looked at last week. So if you don't want that, you just want the skeleton, you can come in here and comment out line 32. And then the function that draws our skeleton is line 33, which is called draw skeleton 25B. So what I did is I created two functions. I created a function that is just draw skeleton. That uses the old code. So if you happen to be training or using a model that is the 25 model, you can use this function. But since we're mostly working off 25B in this class, I add another function called 25B, and that will draw our skeleton using the new key point setup. All right. So let's take a look at the code, and I can just talk a little bit about how it works. So there's a lot of code in here, and we can just, it's probably easy just to break this down into a line by line sort of function, but then it repeats quite often. So the first thing we're doing is we're going through all of our pose key points, and we're then going to look at the array of remember there's 75 total key points, right? So for each XY key point, there's an X, a Y coordinate, and then there is a confidence value. And that happens 25 times, and that gives us our 25 key points. One of the tricks of 25B is that there are no values for 0, 1, 2, and 3. So the first, second, and third key points don't ever return anything. I have no idea why that is. It's just how they set this model up. So we don't need that. Next, we want every key point for like whatever is the next index. So the next index would be index 3, which is technically the fourth. It turns out that is the right eye. So what this is doing is it's going into this key points array, which again is 75 points, and it's just looking for the 10th and the 11th values, which happen to correspond to the x and y for right eye. One funky thing that we pretty much have to do every single time is we have to check to see if this value isn't 0, 0. So if the value is 0, 0, that basically means the model doesn't think this thing exists in this image, right? So if you're doing a model, or if you're playing a video that is mostly waist up, it will probably never find your legs or feet. And you want to check for that because as we draw our skeleton, if you don't do a check to see if this thing isn't set to 0, 0, what it'll do is it'll draw a bunch of lines to the top left corner of your image. So for every one of these key points, we just check. We first get the x and y values, and then we check to see if the x and y are equal to 0, 0. And this is just a thing of like, basically what we're doing is we're adding those two values and seeing if it is 0 or not. And if it isn't 0, then we say that the key point does exist. And if it is equal to 0, then we say the key point does not exist. And this will make a little more sense when we go down and actually draw those. So we go through every single key point, and I've gone ahead and assigned each one of these to what value they are. So it should be pretty clear. It should be pretty clear that right eye is index of 3, which is technically the fourth. Left eye is 4, and then right shoulder is 5, left shoulder is 6, right elbow is 7, 8, all the way down. So my hope is that the name of these variables is fairly clear, right? So it's just like bottom head, it should be the bottom of the head, which is this, like you almost think about that, I guess, is more of a chin. They didn't really name these, so I just sort of gave them top and bottom of the head. So once we have all of our points, which again is just like really annoying that you have to go through and say every one of these points get the x and y and then check to see if it actually is not 0, 0. Once we have those, then we can go ahead and draw our actual skeleton. And you'll see here, I basically check to see if, this is actually, let me comment this. So these are the dots here. So if you don't want dots, anything that says if exists and then a circle, you can just comment all of this out. So you can select everything and then just hit command / I guess, and that will comment that code out. So if that is commented out and then we hit stop and then run again, you'll see you just get the solid lines. So the skeleton has built-in dots and lines, and it's kind of up to you if you want to play with those or not. So this is where we draw our lines. So you kind of have to like build up the skeleton line by line. So first we check to see if the top of the head and the bottom of the head exists. And if they do, then we draw a line that goes from the top of the head to the bottom of the head, right? So it just goes top to bottom. Next, we look for the eye positions to see if the right eye exists and the left eye exists. And if it does, then we draw a line. So you'll see that when the body sort of shrinks down in this case, sometimes the eyes disappear. And then we check to see if the right shoulder and left shoulder exist, right shoulder. So basically now we're just drawing our skeleton, right? So we're just drawing the individual components of this. And lastly, we get down to the feet. Feet are really, really confusing. I didn't really know how to draw feet or like the right way to draw feet. So basically, there's an ankle position and a heel position. So like we kind of draw like a 3D triangle to connect the heel goes to both toes, and then the toes go to the ankle as well as does the heel. So it's like sort of it's a pyramid actually, I guess is the best way to describe it. So if you want to comment this out, like maybe the best thing to sort of understand to see what draws what is if you just comment out lines and then run it, you can sort of see how stuff disappears. So that's the entire skeleton. So if you want to do something with this, like there's a lot of stuff you could do, right? You could use this code where it just gives you the points. So you basically check to see if this point exists, right? So Steve had some code here where he was drawing an image at these points. So you could certainly do that. You could draw an image at these points. Maybe what you want to do is take each one of these lines and then offset it. So like one thing you could do, which I was going to maybe like plan to write a little bit of code this week to show this. One thing you could do is let's say you want to make the head, but you want to draw a little bit of depth to it. So one thing you could do is move both the x and y values a little bit. So maybe we do, let's move the x value -5. So what we're going to do is we're going to create one line straight at the head, and then one line offset to the left, and then one line offset to the right. So this is our left offset, and then we'll do our right offset, which will be +5. So we should get parallel lines that move down the body. Let's stop this and see what this looks like. Yeah, so there we go. There's our head with 3 little hashes. So you can do a lot with this by sort of playing with these dimensions. Like another thing you could do is maybe you want to create almost like a shifting rectangular, sort of torso. So it's almost got like a moire pattern or op art pattern. By taking those 4 points, we draw them all as one line, but you could do like a rectangular or trapezoidal shape with those by just taking those points. So there's a lot you could do with this. It's sort of up like, what do you want to do? If you've never written P5 before and need help with code, let's just talk about what you want to try and do, and we can do that. You could draw curves or arcs between these arms. So instead of them being straight, they're more like, I guess you could even do ellipses. You could actually do an ellipses that says like between those 2 values, like give me a bit of a dimension or whatever. So there's lots of fun things you could do with this. But I just want to show you that this code exists, and here's where to play with it. Yeah, so from there, that's sort of the skeleton. Any questions about the skeleton model? Silence. Okay, so I'll remove this, and then I'll just resave this, and then you can always go to this URL and get this skeleton model. I'll leave it as the bare bones version.
I have a question regarding the dots.
Yeah.
So if you want the dots, the space between the dots to be tighter, so like if there's, the video you're using, there you can see the dots, the trails are a little, I don't know what the best word is. I just said tighter, but there's not much space in between the dots. Is that dependent on the speed of the video, or can you control that within the code?
So right now, what this thing is doing is just it takes every frame, so it's actually the speed of your video essentially. So there's a couple of things you could do. You could draw another dot, like you could fake a second dot in by like, it would probably be a little bit more complicated to take all of your data, but also have access to it across every frame. Right now, this just looks at your data for each single frame. But one thing we could do is we could load up all that data ahead of time so that you would even know like previous and after frames, you could begin to build interpolations in there. That would basically be the solution to do that. The other thing is you could just make your dots bigger or smaller. This last value here controls how big it is. So if you made it bigger, then they would sort of connect more likely because there's less space between each frame or whatever. But yeah, as you begin to build this out, like it's probably like one cool thing I thought about was instead of connecting the skeleton for each frame, what if we made lines that just connected each hand point, right? So it's almost like it's more like you're seeing the distance or the movement of individual points across time. So that could be something we could play with as well. So yeah, I would say like if you have ideas for things, we can obviously like I'm happy to go in and sort of alter this code and share it with people if that's interesting to folks. Yeah, the challenge here is that because we're using video and it's likely 24 frames a second or 30 instead of like 60, we don't get like every like finite little movement or whatever. So we might have to like fake it and make it look like it exists or not.
Thank you.
Yeah, of course. Other questions or thoughts or comments about the skeleton model? Okay. The last thing I want to show is how to do downloads and make your own video. So P5, unfortunately, for whatever reason, I don't really understand why, but they don't really have a good way to generate video from P5. There's a thing called, I believe it's called Capture CC, but it's like very heavy to actually implement it. So I would generally say that if you know what you're doing in P5, you can probably implement it. But if you don't know what you're doing, it's pretty complicated, and I honestly don't love it. So I'm just going to show you a really quick and dirty way to generate video, or like the way that I generally do it. So as I mentioned last week, there is this variable called download, and by default it's set to false because we don't want to download all these frames. But if we did want to generate a video, the solution to do this is to set this to true. And then you can run this sketch. But there's one other issue with this, which is that in our particular video, because it's not super complicated, these frames actually run at real time. And apparently what I learned this week is that Chrome doesn't do well with real time. Like, it basically just can't download videos or download frames that fast. So what it ends up doing is it just skips the frames, which means you don't get all the frames you need to actually generate the video. So the hack for this is I've added it here to setup. So if we're going to do downloading, so if download is set to true, we actually just change the video frame rate and we fix it to like a level like 5. So what this will do is it'll make our video here in the preview run really slow, but that'll give Chrome time to download all the frames. And then if we're not downloading it, we'll just use the built-in frames per second, which, you know, in this case for this video is 24, maybe yours is 30, maybe it's 18, whatever. So this is a way to just sort of like let us download these frames and get Chrome to download them out. So I'm now set this to true, and what it's going to do is it's going to set our frame rate for the video to 5, which won't actually affect our downloads because we're just going to download every single frame as an image, and then we'll compile it using FFmpeg into a video. So we're going to download this at a frame rate of 5 frames per second, and then if you come down here to, where are we? Yes, here. So line 36 says, if the frame count is less than the total number of pose frames, which I believe we actually want this to be. So for my video, I recommend setting this to be like however long your video is. I think my video is something like 400 frames long. Yours might be longer, it might be shorter. You want to set this to a value to, like, you know, for however long you want to make your video for. So I just set this to 400. So if we are downloading, and if my frame count is less than this, because remember that these videos also loop, so you don't want to be stuck in a place where you're just downloading every single frame over and over and over again. So you definitely want to set some endpoint. Otherwise, your computer will just be filled with frames and you'll have to stop P5. And in my experience, stuff tends to get locked up and then Chrome crashes and then you're in a weird hell zone. So anyway, if the frame count is less than however many frames we set and we are going to download them, then what it's going to do is it's going to download a single frame, and it's going to use the frame count. So it'll be like 0, 1, 2, 3, 4, 5, however long our frame count is. And it's going to use a thing, it's going to be 0 indexed, so there'll be 4 zeros. So if it's the first frame, it'll go 0, 0, 0, 1, and the next frame will be 0, 0, 0, 2. It's probably clearer when you actually just download it and see what happens. So we're almost ready to hit play here and actually download these. One other thing I want to note, for it, depending on your browser, you might need to go in and actually set your browser to allow you to auto download files. So on Chrome, and it's probably worth Googling if you're not using Chrome, there is, in Chrome, when you just go to settings and you go to advanced, you'll see there's a downloads key here. So click on that. And then the second thing here is ask where to save each file before downloading. This might be on depending on your machine. Turn this to off. If you don't do this, what will happen is every time it tries to download a file, you'll get a little pop-up that says, where do you want to save this? So if you're during 400 frames, you'll have to hit yes or like accept like 400 times. So you don't want to do that. It's like a nightmare. So make sure this is set to off if you're in Chrome. I assume for Safari or Firefox or other browsers, there's probably a similar thing. So now we made sure this is off. Let's go over here to P5, and I believe we're finally ready to hit play. So we can just hit play, and what will happen is you'll just see the bottom of my Chrome browser will just fill up with frames. So let's just go ahead and do this. And you know what? Sorry, one second. I'm going to delete these. I'm going to set mine to be much lower because I don't want to sit here and watch. We shouldn't have to watch me download 400 frames. So I'm going to set mine to be really short. You should set yours to be whatever length, you know, your video is. So mine just download loosely into my downloads folder. And we're just going to come in here and delete these. And the reason I'm deleting these is because if I don't and I hit play again, I'll get like step 0001 space parenthesis 1, and I have to go in and edit all the names, and it's also a mess. So if you screw up, just make sure you delete all of your files. Why isn't this deleting? Come on. Oh my God, seriously. Okay. All right. So I'm going to set this to be, let's just set this to 60 so it downloads really fast. My video will be very short, but it's fine. Oh, that's interesting. Why is it going over 60? Oh, okay. So you don't. I should fix that. So there's actually a way. This overwrites pose frames into the length of how many frames are in your JSON file. So that's on me for making it look like I set a variable somewhere that I didn't actually set. Okay, so I just hit stop, which is fine. It's going to download all the rest of the frames for me, and then I can work off that. So we can either edit this file, edit this line 24 directly by saying, equals 60 or whatever, or for most of you, it's fine just to let your computer download all the files you need. So now that I've got all these, I can just go back to my Finder. And my Finder is so slow. I don't know if anyone else has this issue, but I upgraded to Big Sur like a couple weeks ago, and my Finder is like on a 5-minute delay for everything now. It's a nightmare. So I don't know why. I've tried to fix it in many ways, and it always seems a little slow, but that's all right. So what we're going to do is let's just assume that you've got all of your PNGs here now, and you want to package them up. So the first thing we're going to do is just select all of the frames. So I'm just going to select a portion of these because I don't want to wait for the rest of those to show up correctly. So go down here. So select all of your frames. I assume most of us are on Mac. So if you're on a Windows, I hope you know the trick to this because I have no idea how to do anything in Windows. But if you just select all of your frames, so just Shift select, and then you hit the right command, and then go to New Folder with Selection. So I'm going to copy all of them into a new folder. And you can just name this like, whatever you want to call it. So again, it's like kind of up to you if you remember what it is. Let's call it vid files. Okay. So the last step is probably the most annoying, or perhaps the scariest to people, and that's we're going to use FFmpeg to combine these. So the way to do this is we'll open up the terminal. And I think my guess is that all of you have FFmpeg installed. You just might not know it. Because most applications build some version of FFmpeg behind the scenes. So if you've never used terminal before, don't be scared. We're just going to write a little bit of line of code, and then we're going to show how it works. So the first thing is we're going to type FFmpeg and then -i. So we're going to use the FFmpeg tool, and then we need to give it an input. So the input is going to be this folder path. So the way to copy a folder path, the best thing to do is just go into Finder, click on the folder, and then hit Command C, and then come back to Terminal and hit Command V, and that will give you your entire path. And what we need to do here is we want to write %04d.png. What this says is it says look for all of the files that have 4 digits, right? So you can see 4D. This stands for 4 integers, but whatever, close enough. So this is going to say look for all of the files in order that use %4D in this folder. And then what we want to do is, this is the part I always, so the next thing to do is type -R, and this is where you put in the frame rate of your video. So in my case, it was actually 23.98, but like who cares? Let's just call it 24. And then this is the part I never remember. I always copy this code from somewhere else because I just straight up never remember what it all stands for. This will allow your code or your video to open in QuickTime. If you don't use this, it'll say your video can't be open in QuickTime. So I'm going to copy this into the chat in just a second once we've got it ready to go. This stuff is just like making sure the codec is correctly formatted for QuickTime. And then lastly, we just need to give it the name of where our video should be. So usually what I'll do is I'll come over here and I'll copy this path. And I'll hit / and then I will give it vid_files.mp4. You can call this whatever you want. I just tend to call it to match whatever the folder name is, just so I know what it is. And then with this, you're ready to go. So your path is likely different because this is on my computer. So see users /Derek Schultz /downloads. Yours is probably something else. It's like, users, whatever yours is. So just copy and paste that path so you make sure you have it. So the key stuff here is this %04d.png, the -R with your frame rate, and then all this codec crap, and then where you put the file. And once you've got that, you can hit return. Of course. So why is that? Let's just see. Oh, sorry, I made one mistake. These files are named step0000.png. So we need to make an edit to the FFmpeg file because it can't find the name. So if you've already ran this and you got an error message, if you press up, the up key, it'll return you back to where you were. And then unlike a text editor, you can't just click in to edit this, right? You can't just click to start here. What you want to do is you want to click Option Click. So Option Click will allow you to place your cursor where you want it to be. So we're just going to place this back here and we're going to do step in front of this. So I'll copy and paste this into the chat one more time. Sorry about that. There's a difference between the code I write and the stuff that I've stuck in P5. So now if we run this, this should run correctly. And this will just basically turn our frames into video. Yep, and now it's finished. And if I come back here and go to vid files on my Finder, okay, here it is. So it did load fairly fast in my Finder. If I hit play or hit the space bar, there it is. So Laura, it seems like you're getting an error with FFM. Did you make sure it's FFmpeg? PEG? Looks like you have FFmpeg. You just make sure. If you do get command not found FFmpeg, that might mean FFmpeg isn't installed in your machine. In which case, FFmpeg install. Are you on a Mac, by the way? Oh, okay, yeah, you're right. Okay, are you on a Mac? Yes, on a Mac. Okay, install Mac. Okay, the easiest way to install it is, assuming you have admin access at your level, copy this into terminal and run it. And if it says brew isn't installed, then you can run this. Did everyone else get a video created? Okay. Anyone else stuck or have issues? Cool. If you do, just drop me a Slack message and we can get this installed. I wish FFmpeg were a little bit more user-friendly because it's very powerful, but if you've never used terminal before, it can feel a little scary. But I will note that you will see something that looks like this pretty much everywhere. And sorry, I probably should make this bigger so you can actually read it. You will see throughout our notebooks, you'll see something that looks like this, which is just basically like, here is the input. I want a bunch of files with either, like mine will usually say %09d because I use a 9 index number counter, and then frame rate, codec stuff, and then output. So we'll definitely, like when we do the BodyPix stuff next, we'll see some things that look just like that. So it's kind of just like getting in the habit of downloading, putting in a folder, writing the, like copying and pasting the command and then using that. It just kind of wrote. I will say that if you have something like Adobe Premiere or After Effects, and you just feel more comfortable using those tools, you're more than welcome to just like drag the folder of images in there. And I know like After Effects and Premiere will turn that into a video and then you just export it from there. I find opening After Effects or Premiere just to do that to be a little slow, but if you're more comfortable with that, please feel free. All right, any other questions about creating video from this? We're not going to use P5 for the rest of today, but I think we'll probably come back to it later for some other sessions. But I'm happy to answer any P5 questions that anyone ever has, although I often just Google the answers. So I'm about as much help as anyone else could be, but I'm happy to help where I can. No other questions? All right. Let me give you the notebook for today's class, and then I don't think we really need to worry about rendering it. We'll take a quick break. We'll come back and we'll start fresh off of this. Yep, that should work. So this is the notebook for today's class. So we'll be doing pose segmentation for the rest of the class, and I'll walk through a bunch of demos and examples and show you some of the stuff we're working on. So why don't we take a 10-minute break? So we'll come back at 23 after, and we'll just pick up with this and we'll go through the rest of class. Sound good? All right, so see everybody in 10 minutes. And I'm gonna go ahead and share my screen. Before we jump into the pose segmentation stuff, because I know myself and I might run a little bit long, I just want to talk a little bit about homework for next week. Obviously, your homework is to really like think about projects that you can start to create or those sort of things. But for next week, we will have another section of videos. So here are the films I would love everyone to watch. So again, we'll create a little thread in Slack for anyone to add comments if they feel like it. This should be, I'll say, I think it's the most fun selection of videos we're going to watch, mostly because it's almost like little music videos for everything. So this is a list. They're fairly short. Most of them are, I don't think any of them are over 10 minutes long. So it should be a nice, like sort of relaxing, easy watch. So yeah, these are the videos to watch for next week. The other thing to do is if you could bring in one high-res image that we'll play with. So the first thing we'll do is something that will be maybe a little less musical, but we'll talk about some musical concepts we can apply to imagery. So bring in one high-res image, and by high-res I mean like maybe 2,000 or 3,000 pixels in the long dimension. And then for the following week, we'll do some stuff with actual music. So if you want to also pick out a song, maybe a short music clip, 30 seconds, a minute, we'll look at how to do some stuff with that. Sound good? All right. So this is obviously linked to from the top of our Slack channel. So if anyone has any questions about these, and obviously, as always, you're welcome to recommend, like, hey, I saw this thing, it kind of reminded me of this. Please share those videos as well. in the Slack channel so we can all watch those. But we'll mostly talk about these, I don't know, 10, I think there's 10 here. So mostly talk about those. And again, they're more or less, depending on how much time you have, they're more or less ordered from most important in the discussion to least important, or like less important. So if you only can watch a couple, I would say start at the top and work your way down. Right, so let's move on to pose segmentation. So the link for the Collab notebook is already here in chat, so you can go ahead and open that. One thing to note is that this notebook does not require the GPU, so you don't need to worry about getting a GPU assigned to you or anything, so free Collab will be totally fine for this. Because it doesn't run on the GPU, it's a little slow, so I'm going to work with a very short clip, like a 6-second clip of video, just to sort of show how it works. So let me just grab my video here and drag it into my Finder really quickly. So here we go. So again, you can upload your video by just dragging it into the Finder side panel here, or you can hit the little upload button to upload it. All right, so let's talk a little bit about what BodyPix is. BodyPix is a machine learning model that allows us to do actually a bunch of different stuff with poses. And a funny thing about it is actually meant to run on the web. So if you are a web person and you really like React and or JavaScript, you might actually find this really enjoyable to use. I'm using a hacky version of it that allows us to run Python, which actually has less features in it. So if you are definitely more of a web person, you want to try some real-time web stuff, the original repo is this link here. And there's a bunch of stuff that you will probably be able to, oh, thanks, Sean. Yeah, so you'll be able to learn a bunch of stuff. There's some examples here of, I guess, I don't think this is React. I think it's just little JavaScript. So if you want to go through that, you can. But what you'll see that it can do is it can do pose detection. So just like OpenPose, it can give you key points and it give you poses. But another nice thing is it can also give us these segments. So see here how you've got sort of blue, green, this lighter green, the arms are sort of pink and orange. So this is what we're going to use. We're going to use the pose segmentation part of this model. In my experience, the skeleton system is a little less reliable than OpenPose. But if you are looking for something real time, this might be the best, like this might be a better solution for you, especially if real time on the web. So this runs on something called TensorFlow.js, which is just better optimized for doing stuff on the web. So if you're interested in that, maybe take a look at it. I'm happy to maybe walk through a little bit. I haven't written like good JavaScript in a good couple years, so I'm happy to help if I can, but I am definitely not the best at it. So give it a shot, and if you can't figure it out, I can probably help. One note I will say is that this model is not the cleanest. You can see here in their results, this is a segmentation system, right? So it's trying to segment the person from the background. It's a little messy. I don't know if that's because of their data. I don't know if that's because of the training data they had, or if it's because of the model itself. So it's faster, but it is not very accurate. I also looked at a model called DensePose. Yeah, I looked at DensePose this week, and it was a little bit better accuracy-wise, but had some other issues. So for this class, I'm just going to show BodyPix. If someone's interested in something a little bit more accurate, I'm happy to show DensePose, but it can cause other issues. So yeah, with that, we'll look at BodyPix really quickly. Go ahead, Diego. Yeah.
Have you tried the runway ML rotoscoping feature?
Yeah, so we'll talk a little bit about, so basically there's a couple different ways to think about segmentation. The one is if you just want a silhouette, then there are way more options, right? So if you just want a silhouette, stuff like Runway's tool is likely more accurate. I will say the Runway tool I find requires a lot of work. Like rotoscoping still, requires a decent amount of effort. And I find that in my experience, I'm still going through frame by frame to just sort of pick out like what parts it should be looking at. It's faster than hand rotoscoping for sure, but I would say it's more accurate than this, but I'd say it's still a decent amount of work, and it only gives you a silhouette, right? So it doesn't give you the individual body parts, which is what we're going to look at today. Any other questions? All right, cool. So we'll go through just how to set up BodyPix. So the first thing we're going to do in our Colab notebook is just run this top script, which is just going to install BodyPix as well as some other tools we need. So again, you just click in here and you'll hit Shift Return or the play button and it should run. Shouldn't take more than a couple seconds to get everything installed. So with BodyPix, there are a number of different model options that you can use. Because this is meant primarily as sort of a real-time tool, they have a number of real-time models that are faster but less accurate. And then they have a couple that are like more accurate, quote unquote, but a little bit slower. So the way to look at all of the models available to you is to run this line of code. We're just going to list out all the models available to us. So here are all the models available to BodyPix. You will probably say, what the hell do any of these mean? And the repo does describe a little bit about what's helpful with each of these. Let me see here. Where are our models? Well, I'll find a link to it. But essentially, things that say MobileNet are essentially meant for mobile phones and/or faster, like you need more performant and less accurate. ResNet 50 is the more likely of the more accurate models, but it'll be slower. So, and then basically the stride, you want the lowest stride possible, and in most cases, you want the float or the quant one. So I'll add a link to the documentation for these stuff here. But for most of us, we're going to want for this course, for this class, we're going to use the ResNet 50 because it's the most accurate, and you'll see that it isn't even really that accurate. So again, just if you want to do more performance stuff, you might get away with the MobileNet, but you'll have lots of issues, I think, with other things. So so next thing we need to do is just like what I always recommend doing when you start a model is run it on one image first before jumping directly to video, right? Because you want to see how accurate it is. You want to see what it does, what you can do with it before trying to finagle like video into working. So what we're going to do is we're just going to download a single image. This is going to download an image from iStock Photo with the watermarks and everything, and we'll be able to use this. So if you run this cell, this will just download an image for you very quickly. And we go over here. We'll see there's our image. So the next cell will allow us to display it in Colab. So if we run this cell, there's our image. So it's someone standing. And so then the next thing we want to do is we're going to draw our masks. So there's a command in here in BodyPix called tf_BodyPix and then space draw mask. So let's take a look at what options we have available to us, and then we'll look at some examples of how to do that. So we'll just run this cell, which will give us the help documentation for drawing a mask. And so what you'll see here are all of our options. I've highlighted most of the ones we only need. Kind of up to us. If you want to play with more of these, I'm happy to discuss what they mean. But essentially, we need to give it the model path, which is the links or the URLs we looked at before. We can skip model architecture because it infers it from our path. And then we will want to look at stuff like threshold, as well as you can see here you can get parts. This is where we'll look at getting the parts back from our model, as well as looking at how to add the overlay on top of our model. So this might not make a lot of sense until we look at the first example, but kind of looking at this next to the first example will be helpful. So let's look at the first example. So what we're going to do is we're actually going to look at what MobileNet produces. So this will be the very fast model, but it won't be as accurate, and we're going to look at it just sort of see what it does for us. We're going to use our source image, which is this model, this image here, and we're going to output it to a file called standing mask, and then we'll look at MobileNet. Threshold. So threshold is, one of the interesting things about these particular models is what they do is they provide a confidence value on every single pixel. So every pixel in your image, what it does is it takes the image in and it says for every single pixel, I think this is the body part I'm looking at, or there's no body part here. So it'll say this pixel is the right leg, and it'll give you a confidence score. This threshold is that confidence score. So if you say, I want something where you're 50% confident that this is a right leg, show that to me. And what that means is if it's 25% confident, it means it won't show it to you. It'll just show you anything above 50% confidence level. So we'll play a little bit with threshold in just a minute, just sort of see what it does. And lastly, we're going to output the mask on top of our image just so we can see how it overlays. And then we're going to use colors to sort of help us determine parts from each other. So let's run this cell and take a look at it. And it'll be a little bit slower just because it has to download the model directly before outputting it. So remember, this is MobileNet. So this is what it did with a 50% confidence. So you'll see it didn't catch a lot of the hair. There's always a gap between the shoulders and the head. The torso, which is what this yellow part is, actually the torso looks pretty good. Where we run into problems are in legs. So you'll see this believes it's like upper part of the leg. It doesn't capture any of the feet. So this is MobileNet. This is why we're not going to use this, because this is not good. The skeleton might be better. I haven't really played with the skeleton too much, but you can see this is kind of crappy. Like, why does it think part of the bottom leg is here at the upper arm? Like, not useful. More or less, like, if I were to look at this and this were the only option available to me, I would just junk this project, because like this clearly isn't good enough. We can play a little bit. Let's play with threshold a little bit and just sort of see what we get. So let's say we lower our threshold value to 25%. So instead of 50, we go, halfway down. Run this again. And now it's capturing a little bit more of our legs, but it's also pretty bad in other places. It captures a little bit more of the head. Misses a bit of this hand. This hand actually is okay. You'll see there's a lot of gap. There's a lot of overlap. I have a suspicion that this is just trained on really poor data. I think, they probably very roughly mocked in where the overlaps are, and they did a really poor job of it. That's my guess, but I could be wrong. So if we set the confidence to be 75%, let's see what we get there. Remember, this is a high confidence that that pixel value is a part of this image. And you'll see maybe it's a little bit more accurate on this hand, but now it skips this hand entirely. Starting to skip the shoulders. Again, really bad at the legs. So this is MobileNet. I would not want to use this if this were my project. So let's compare this to ResNet 50, which is the other model, which is supposed to be more accurate. So we'll just change out the model path, and we will keep our threshold value at this. There's also this other thing called internal resolution. If you turn this up, this might give you a better result, but it will also slow down your response time. So by default, I think it's set to 0.5. So if we want the slowest but most accurate version, use this model of ResNet 50 and then set an internal resolution of 1.0. So let's go ahead and run this. We just need to download our model. Okay, so here's our image. So if you remember seeing what the other one looked like, this looks much better to me. Now again, it's not perfect. In fact, it's in many ways not perfect at all, but it is far better, right? It captures the hands pretty well. A little bit of issue around where the hands meet the leg, but in general, it's much cleaner. It seems to definitely understand where upper arm and lower arm is better. Hair is fairly accurate. Torso, maybe less so, but it's okay. For whatever reason, this model tends to really struggle with feet and legs. I've actually noticed this with PoseNet as well, as most of these models don't do well with feet or legs, probably because there's lots of angles or whatever your feet could be in. So this is with 1.0. You'll also see there's a little bit of artifacting here. I don't know if that's because of the watermark or just because of how this model is trained. We could try turning down our internal resolution, or maybe turning down our threshold a little bit. Like, what if we did 375 for threshold? So I do notice this model is a little bit slower. But here we go. Now we're almost getting worse. So maybe this is just this image. Maybe this is the way it trains. I do notice there's some artifacting with this particular model. But in general, I think it gives me much more accurate sort of body parts here. So we could try using the default internal resolution and see if that changes anything. No, that's actually better. Interesting. I wouldn't have expected that. That's actually not terrible. Well, okay, so let's use that going forward. So we'll use the internal resolution of 0.5. Now again, we're testing this on one image. Who knows if that's going to be the same across the board, but it's worth trying to sort of see. Any questions about this so far? No questions. Okay, moving on. So this just shows us how to roughly mask. And you might be asking yourself like, okay, well, how do I actually use that mask? Or like, what can I do with this? Right? Like, this is cool, it's color coded, but like, I don't really want color coded stuff. I want to do something with this. So now we're going to dig into working directly with masks. So we're going to get a little bit more into the code here. And if coding isn't your thing, that's totally fine. You can kind of just gloss over and just look at what the results are. But we'll talk a little bit about what's going on here. So to start with, we need to load in a bunch of these tools. This is stuff like TensorFlow and the BodyPix API. And I think some of you have maybe taken my OpenCV workshop before. We're going to use OpenCV for this, as well as NumPy. I'll cover most of the details here. And again, really what we want to do is just get the basic conceptual idea of how this works, and then we'll deal with how to actually do it in maybe our own individual projects. So go ahead and run this cell. And then the first thing we want to do is we want to load in our model. So again, this works a little bit differently in that the first thing we want to do is load in our model, and we do it in a variable rather than in this whole script command. So we're actually going to load in that ResNet model. So this takes in a little bit of a different API. So we'll use the BodyPix model paths and then this. And then we're going to change, like we said, we'll use an internal resolution of 0.5. So you can go ahead and run this cell. I don't think much will happen here because I think it's just going to load in something that we've already downloaded. Yeah, so that's pretty quick. So now that we have our model loaded, the process for this is we will take an image and we will pass that image to the BodyPix model and get a result back. And then we can look at that result in mask form. So that's what the next cell does. So we're going to use OpenCV2 to open that image. So again, this is just open that standing image. And then we're going to set an output path for where that image should go, or like when we save out the result. And then because we've just generically made this path, we need to make sure it gets turned into a folder. That's what this line does. And then this is the magic sauce here or whatever. This is where you pass the image, right? So this is our image. You pass that into the model using the predict function, and you get back a result. And then you convert that result into a mask. And when we get that mask, we can set a threshold. So where do we set our threshold to appear? 3.75. Let's just keep that a little bit higher. So we'll do 0.5. And then we're doing some stuff like converting it to NumPy. Don't really worry about that too much. So let's run this cell. Nothing will happen because all we're doing is saving our results and we're saving out our mask. So let's run this cell. And that's it, it ran. So now what we want to do is we want to actually look at our mask. And because the mask is in a format of basically mathematic values, I highly recommend that so actually one thing you can try to do is you can try to actually look at what the mask looks like. So we can do that first. So let's take a look at this. And we know our mask is an image, right? It should be, maybe our color coded or something else. We can use this command called cv2_imshow. Let's just say display this in the cell below. And then we're going to pass in our mask value. And if we run this, we'll kind of have an issue of this. It's all black. What the hell happened here? So if you get this and you get this far and you're like, I think it's broken, it's not broken. The challenge here is that we would assume that our data is in the form of pixels, right? Where it's like 0 to 255, right? That's an RGB value. But this mask is actually in the form of 0 to 1. It's saying this is a part of our mask or this is not a part of our mask. So this is displaying 0 and 1 pixels. So I'm sure if you somehow mess with the contrast of this image somehow, you could see where our mask is. When you run this, you might just be like, oh, what the hell is this? So let me show you a couple of techniques to figure out what data format your image or your mask is in. This is a common thing you run into when dealing with new machine learning models is you don't know what format the data is in. So I've got a couple cells here just to sort of explore what happens. So what we're going to do is we're going to print out some values. So the first thing we're going to do is we're going to look at the shape of our mask. And shape will generally return height, width, and then how many channels it is. And an RGB image is 3 channels, right? Red, green, blue. A grayscale channel has 1 channel, and sometimes it might not even say a channel because it's just assumed it's one channel. Next, we're going to look at the minimum value of our mask. That will give us what the lowest value of this mask is, and then we'll get a minimum value of the highest value. And then we're going to look at is what are the values larger than 0. And this would hopefully return maybe 0.5 or 1.0, what sort of values do we get? So let's go ahead and run the cell, and then we'll walk through each of these one by one. Okay, so the size of our mask is 1024 by 1024 by 1. My guess is if I open this image, it should be the same size as my image. The minimum value of the mask is 0, and this should be maximum. Let me change this here. Maximum and mp.max, yeah. So the maximum value is 1, right? So again, 0 to 1 is how this mask works. And then something funny that I didn't realize about this is it's only returning zeros and ones. And the reason for that is that if you want something else, you have to pass your mask to a new function to get something else out of it. So what we can actually do is if we actually want to look at this mask by itself, what we can do is we can multiply all the values of the mask by 255. So why do we do 255? So this is, remember it's 0 and 1. So when 0 is 0 and you multiply that by 255, you still get 0, right? So it's still black. When it's 1 and we multiply it by 255, we get white, right? So in grayscale, it goes from 0 is black to 255 is white. So when we run this cell, we should see our full mask. And sure enough, there's our mask. So there's our standing person and all the pixel values. So if it's assumed to be inside of the mask, it will be white. If it's outside, it'll be black. So that's just basic masking. Any questions so far? Okay, so now this is great. We got a full body mask. We can start to play with that. But what if we want the individual parts? So there's another function here that gives us result.getColoredPartMask. So remember that result is up here. Result is the result that we got back from our BodyPix model. So we want to, from the result, get the colored part mask. And then, so this is just going to return what we saw before, which is those colored sections. So if we use this and we set this to this variable colored mask, and then we go cv2_imshow and run this, there is our colored part mask. So you'll see, maybe this wasn't apparent, or it wasn't apparent to me when I first looked at the color mask, but you'll see the face is actually divided into two parts. So there's half of the, this is the right side of the face, and this is the left part of the face. The other thing that also still confuses me to this day is I'm looking at this and I think this is the left part and this is the right part, but the model sees it from the actual pose of the person, right? So to the person, this is the right and this is the left. So that's how it thinks about left and right. So just be aware that that's like one thing you might get tripped up on. And then you'll see there's some other color bands here. This is for, this model separates both left and right, but also separates back and front. So this is sort of saying like this is somehow some form of back of the arm. And I think if you look at the corners here, you'll see this is supposedly the back of the torso, which isn't realistic, but so it goes for a person standing forward. So there's some funky little issues with this mask, but this at least helps us show what we're looking at. And you'll see again, the feet are kind of janky. So that is the colored mask. That's great, but let's say we want just an individual point, or we want just one of those pieces as a mask, right? So now there is another part in result. There's another function called result.get_part_mask. And what you pass in is your original mask, so just that grayscale mask, and then you request the exact part names you want. And all the part names are listed here. So there's a key in the original repo of all the body part keys and their names. So you'll see it's left face, right face, left upper arm, front, left upper arm, back, right upper arm, front, etc., all the way down. So these are the parts you can get back. And if you want a part in particular, what you can get back is you can pass in part names, and then make sure you use square brackets. And then inside of square brackets, you can request each body part as a individual string. So left face, comma, right face. So if you want just, let's say I want just the left face, I can do this. If I want 2 or 3, then I can do right_hand, and let's say left_foot. So this will return just the individual mask portions that are those little areas. And then what we can do is, again, remember that this mask, again, returns a 0 to 1 value. So we want to make sure we multiply our mask by 255 so it's visible. So if we run this, here are our parts. So I got left face, right hand, And did I name foot wrong? Why didn't I get a foot? Left foot. Maybe it doesn't think there is a left foot. That'd be weird. Let's try right foot, see what we get back from that. That's interesting. Let me make sure I didn't name that wrong. Well then, maybe something is broken here. Well, we'll come back to that. Let's assume we don't want any feet for now, since the feet are so bad anyway. I don't know what's going on there. I have not noticed that yet. Okay, so we'll get our left face, or is that right face? I can never remember. Left face and our right hand. Okay, so those are our masks. Now, the next step is, okay, this is great, but what if I want that actually masked, right? So you can think about this in like Photoshop, you would actually apply the mask in Photoshop, draw black and white to get just the image popping out of it, right? So the way to do that is to take this mask and to perform an OpenCV option called CV to Bitwise. And so this sort of does, it says where there is a 0 pixel, ignore that, or just keep the background as black. When there is a white pixel, actually take the white pixel from the image and use that. So you pass masked image into cv2.bitwise_and, and then you're passing in the original image. I forget why you pass in the original image twice, but you do. You pass in the original image twice, and then you say mask equals, and then you pass in your mask part variable. So in this case, that's here. That's where I got back these individual parts. So you pass in mask equals part, and that should return an image that is where the white parts are. We actually see the image come through. So we go. So there is our masked image, and there's our hand. So we could switch this out. Like, let's say we want both. Maybe we just want the left face, and the right face. So we just want faces. So we could run this cell again, and there is our face. And then we can come down here, and we can run this cell again, and there's our face combined. So this gives us the two parts, left and right. Lastly, you may hate that we have like a hard edged mask, right? You want to soften that a little bit. The way to soften it is to do a rather complicated set of code, which involves blurring the mask, right? So we're going to blur our mask a little bit, and then we're going to, so we'll show what that looks like. So blurring uses a convolution. So this always needs to be a odd value. So this needs to be 3, 5, 7, 9. And then this sort of sets like the threshold for that. So if we run this will be not a terribly large blur, but it'll definitely like blur it pretty well. And then we need to convert that mask to a three color channel. So what we do is we do a convert color, and then we convert it from gray to BGR. OpenCV uses BGR instead of RGB. Don't ask me why. Probably some legacy of like 80s code or something, but it uses BGR, so we want to make sure we convert to BGR. And then what you do is you do a multiplication. The idea here is, again, still the same, that if you multiply something by 0, it should stay black. If you multiply it by 255, it will always be 255, right? There's a clamp there. And anything in between, it'll multiply the gray value times what color it is, and you'll get sort of a half gradated sort of color there. So let's take a look at what these two together. And so we should see at the top, we'll see we've got our little bit of blur on this person, and our mask looks like this. So a little bit of a blur on that mask, and we've got a little bit of a softening of that overall mask. Yeah, Diego, go ahead.
There's an option in the very up in the code,
yeah,
for blur also in the mask. Before you do the mask, it appeared when we put help.
Yeah, so the difference here, so it was what here? Was it here?
draw mask help.
Yep. So
There's
yeah,
a
mask blur.
blur.
So the difference is that this is a command line script, and what we're doing is we're looking for the individual parts by ourselves, so we can't access that same command. So we kind of have to do the blurring ourselves, which is kind of frustrating. But what it will give us is we'll look at, as we apply this to video, it gives us a much more flexible system to figure out what we actually want to get back. But yeah, it would be nice if there was a function called like get results or result.getPart mask with blur or something. But unfortunately, there isn't. Any other questions about so far what we've looked at? All right, well, let's finally apply this to some video because I think video is going to be a lot more fun than having, like, you could look at that and be like, I can just use Photoshop and not have to learn what all this code means, right? But now that we apply it to video, you can't go in and hand paint each individual frame in a video, right? Like, you don't want to go and do your own rotoscoping. You could, it would take you many, many hours, but you don't really want to. So ideally, we're going to use this to give us some artifact or something close to a rotoscoping effect. And we'll be able to say we want these body parts versus these body parts. All right, so the first thing we're going to do, just like we did last week, is we're going to scale down our video a little bit. So if you haven't uploaded your video, I recommend doing it now. And then what you can do is you can copy the path of your video. And just like last week, you can place your video file in this first FFmpeg command. So when you open this first one will be commented out with that hashtag in the front. Comment that one by removing the hashtag, and then comment the next line out, and you can run this cell. Again, for me, this always leads to an error just because what it does is it scales down the video to a point where you can't actually do it. You'll see here, so it says width is not divisible by 2 because by scaling it, I get a odd width, which I can't use. So I have to use the next one, which is the next cell here, which forces the scale. So it just squishes the video by 1 pixel. So I'm just going to go ahead and run this. Whoops, and it's because I have trim 2. Okay, so that ran for me. So this just made my video a little bit smaller. Again, I haven't had any issues in terms of like actually being able to do larger video with this. The challenge is it takes forever. The larger your video is, and the longer your video is, then it just takes longer and longer. And for this demo, I don't want us to be sitting here watching this stuff forever. So this is like a 6-second video, so it should render out fairly quickly in these tools. Okay, so let's start by rendering what BodyPix does with just with a portion of our video. And what we'll do is we will look at the actual colored masks, right? So then the different segments will be colored according to that color key. So what we can do is we can take your video path. I think for most of us, it'll probably be named this. Paste that path in here. And then we're going to put an output path. This is where we're going to save all of our images. So this will create our folder called output colored mask. You can remove the 2. So this is a way to load in a video using CV2. So last week, what did we do last week? Last week, we just converted them to frames, right? So we took the video and we split them all out into frames. This is one less step because video capture, the CV2 video capture tool, will read the video and it'll read in frame by frame for us. So CV2 video capture just takes in the path to the video. We want to make sure we create this folder, so in case it doesn't already exist, we can create it. And then what we're going to do is we're going to loop through all the frames. So the way to do this in CV2 is to say while cap is opened. So remember, cap is capture. The reason it's called capture is because it's often tied to a web camera. In Colab, you can't use a web camera, or you can, but it's really annoying. So for this, we're just going to use video. But just know that you can do web capture if you wanted to directly in one of these notebooks. It's not really good. It's not good real time because of how Colab works, but you could play with it a little bit if you wanted to. So while cap is opened, and we're going to read in the video, so this will read in every frame during this while loop. And then what I'm going to do is I'm going to set a hard cap of 60 frames. Again, just for this demo, I don't want to be sitting here watching thousands of frames render. If you want to watch your entire video render, you can just remove this and everything after and, but keep the keep the colon. So I'm just going to run with this because I don't want to be sitting here forever during this demo. So what we're going to do is we're going to loop through the video, and at every frame we're going to read it in. So cap.read reads in our frame. So now the file that we were using was called image before is now called frame. Just like before, what we read in is we got the result from it. So we said result equals predict a single frame, and we gave it this frame image. So this is giving the image to the model. And just like before, we ask back for the mask, and then we use the result get colored part from this mask. So none of this should be new. It just is basically taking in the video to produce this video, or to produce these colored outputs. And lastly, this is the one new thing, is we need to write this file as an image. So we're going to use cv imwrite, and then what we're going to do is we're going to take our path here, and we're going to combine that with we're going to take our count. So like when it's the first frame, it'll be 0, 0, 0, 0, 0, however 9 zeros sounds like. So all this says is give me a path that looks like this. So this will give me a path that looks something like right? And it will just change every time we increment our counter. So every frame will get a different number, but it will essentially be this. It'll go 1, 2, 3, 4, whatever. So this looks like a lot of complicated code, but it's just that way because we want to make sure that our path is accurate and other things. It saves us a little bit of a headache to just set this up like this. So you're welcome to copy and paste this code everywhere, and it should more or less work as long as you have an output path defined. And then we pass that image path we're going to pass it in the colored mask, and then we're going to save it as a PNG. So if all of this looks like gobbledygook to you, that's totally fine. Half the time it does to me too. Just know that really all you really need to do to write an image is to copy and paste this and make sure you have an output path variable defined and a count defined. We'll see this in pretty much every cell going forward from now on. So let's go ahead and run this. And then the last thing is like we want to increment our counter. So we want to start at 0, 1, 2, 3, 4. So we just want to make sure that like every frame gets a new name, so we're not overwriting the same file name over and over again. Let's go ahead and run this. And you'll see what it's doing is it's just spitting out every frame count, just so I know, like sometimes when I run this on a very, very long video, I want to know how far along it is. And this is just a nice way to like quickly get that. And we're almost done. And you can guess what our next step, what our last step is to use FFmpeg to combine everything. So again, here is the path to where our folder of images are, right? 0, 1, 2, 3, 4, 5, all the way down. So lo and behold, we see our magic little %09d. This 09 means there are 9 values instead of we were previously using 4, because this uses, oops, not image output. This has 9 digits. And then we have our little magic garbage for the codec here. And then we've got our MP4. So this is where we're going to save the file. So go ahead and run this. And trying to watch a video in Colab is very, very annoying. So I recommend just downloading it. And so there's our video. So I would say this is not the best. None type. Oh, so Kaiman, the reason that happens is, did you remove that that and count cap or whatever? Did you remove this part? Oh, interesting. Do you have a video that has less than 60 frames in it? Yes, that's why. Okay. So if your video is less than 60 frames, you'll get an error message because what'll happen is it's going to try to read in frames that don't exist. So that error message essentially means that like, hey, I reached the end of the video and I couldn't find anything else. That's because this is really set up for more of a webcam usage where it's streaming and it will always get new frames. So that's all the error message means. Yeah, cool. So if I cared enough, I might come back to this and play with these values a little bit more. I might decide to change my threshold, right? Maybe I would say it's 0.75 to get more image data out of it. Maybe I would go back to, maybe I would load in my my model with a different resolution or something, right? All the way at the top of the file here, or where did we do this? We did this here, right? So we loaded it in the model and we set the internal resolution to 0.5. Maybe I want to try 1.0. So you would rerun that cell and then go back down to where you were. For this demo, I don't really want to mess around and try to figure out what happened with this particular video. I'm just going to keep going through the demo, and it might look a little bit janky, and that's just fine. Another thing that would, if I really cared about this video, what I would probably do actually is I would run this command. So what I would actually do is I would run this cell, or sorry, not run this cell, but I would create a new command that said I want to take this video, and I guess it's probably this video I want to take. And I would do what I usually do, which is I would pull this apart, right? So I'd actually say, I want to convert this to, let's make a new folder over here, and then video frames. So I can do pretty much the inverse here, which is that I want /content /video -frames, and then %09d.png. So this does the reverse. This will split our video into frames rather than combining them. So if I run this, and I come in here, see here are all of my video frames as individual images. So here's my video. I can actually see now why this didn't read in very well. This is pretty blurry, right? So probably struggle with the blur. Maybe that's because I compressed it or did something else with it. But what I would do if I really wanted to optimize my mask is I would actually take one of these frames and I would go all the way back up to the top here, what it already did for me, and I would start to test with a single image to make sure I get my values right. That's probably, again, where I would start is I would start with a single image, optimize for a single image, then go to video and try to play off that and see if I would get a better result. And you might find that you chose a really good frame and you optimized for one frame and then everything else didn't really work and you might have to bounce around a little bit to play with these. This is the biggest challenge with this stuff is like optimizing, especially on this model, because I just find this model is not that great overall. But apparently segmentation is not a thing that a lot of people have done recently. So unfortunately, like, this is just kind of what we have as our option. I wouldn't be surprised if like in the next year or two, someone actually creates a better model or creates better training data and we actually get a model that works. That's usually what happens is these things are cool for a year and then like no one touches them for 2 or 3 years and then someone comes back to it and says, hey, I bet you I can actually solve that and make it look really good. And then they do. And we just haven't gotten a new one of this recently. So, you know, again, my video, not great, but good enough for this demo is basically what I'll say. So we generate our colored mask video, but again, that's not really like everything we want to do because, you know, maybe I don't like these colors. You know, what I really want to do, it's actually kind of fun to see this watch like that. That's kind of a nice frame, even though it's not human whatsoever. But there's, you know, our person. So maybe what I really want to do is I just want to play with getting different parts of this video out. Like maybe I want to just isolate the head and just sort of see what the head renders separately by itself as. So let's go into the next step here. So one thing we could also try to do is we could actually alternate between body parts, right? So remember, we're working with frames. We've got a sequence of frames. What if every frame I change the body part? So first frame, I'll take the left side of the head. Next frame, I'll take the right side of the head. Then I'll take the shoulder or the torso or whatever, and I'll basically alternate through all the body parts. So that's what this cell will do. So a couple of things that I've changed here. So first is I've set up a variable here called total frames, and I've combined that with count. So again, if you want to just keep a certain length of your video, so Kaiman, since you have a very short video, maybe you want to set this to 30 or something like that. So we'll set this to a shorter value. And then again, we're going to loop through the frames. You'll see I've added this array here called body parts. And what this is this gives me every single body part. And what I can do then is I can access or request this individual string name by saying, I want body of 0. So this will say, I want the first element inside of, body parts. I want the first element inside of body parts, which will correspond to left face. So if I were to print this value, it would print out left underscore face. So what we're going to do is, a lot of this looks pretty similar, right? So this is, we get our results, we read in the frame, and we predict the result, and then we get our mask back. And then what we want to do is we want to ask for an individual body part. So I'm going to set up a variable called BodyP, and that BodyP is going to take from this array, and it's going to look at my frame count, right? So it's going to start with 0. And then there's a little trick here if you've never seen a modulo before. A modulo returns a remainder, which maybe gets to, like, I don't know, 8th grade math for those of you that hate a math class. Modulo is a remainder. So when my count is 0, and I'm looking for the remainder of dividing it by 24, my remainder is 0. When I ask for the first frame, my remainder will be 1. When I ask for the 24th frame, my remainder will be 0, right? Because 24 divided by 24 is 1, so there's no remainder. So, and the reason I got to have that number is that number comes from here. There's 24 total body parts. So what we're doing is we're saying for every frame, give me, like, basically it's going to loop through this list. So it's going to say left face, right face, left arm. It's going to loop through this entire list, and then when it reaches the end of the list, it's going to go back to left face. So that's what this does. This is very shorthand, but you will see this in many generative artist code because remainders are very important, or very easy to then access this array. So here I've got a loop. I'm going to print this so we can actually see it happen in order. So it's going to print out for every frame, it's going to print out what it's looking for in that frame. And then what this will return is this will return a string, right? So this will return something like left underscore face. So then what we're going to do is, remember we had this function called results get underscore part underscore mask. We pass it the mask, and then we ask for the body part name, and we're going to use this variable and ask for that variable here. So this is, I'm sure this is confusing to a lot of you right now. Just know that we're kind of doing some funky generative art stuff to get access to this list without having to hand write it, right? Because if we had to say, like, if count equals 1, do this. If count equals 2, do this. It would be very tedious, and we'd be doing a lot of cutting and pasting. So instead, we kind of do some math to, like, hack our way through it. So it's a little bit, it's hard to read, but there's much less to write, which is basically the thing that generative artists love, or most engineering people love. Sorry, that was the wrong comment. So once we get our mask, we're then going to do that bitwise function to mask out just that part of the body, right? So this will give us the video underlying and then the body part mask, and we'll loop through all the body parts. Does that make sense? We'll render the video and then we'll see what we get. So you'll see here, it's literally looping through our entire array. So if I wanted to change the order, probably the easiest way to change the order would be change the order here. This is essentially defining the order of operations, or the order of the list in which we ask for these things. And it sort of goes top to bottom. So if you want to change it, it's probably easier to say, let's say I want face last, right? I would just copy this and paste this at the bottom. So you'll see it loop through all of these. And when it reached the end of the foot, it went back to our face. And that generated a folder called output part alternate. And inside of here, if we look at one frame, this should show me well, it's kind of hard to see because this person is wearing a hood, but it shows a little bit of a hood there. So now what we can do is we can take our always lovely, man, I don't know, Colab has a bug in it where now when you open an image, it scrolls you all the way back down to, or back to the top of the page. Let's get back down to where we want to be. Okay, so last step here is we are going to generate a video from this, right? So again, remember that our folder name has changed to output part alternate. We're still going to read in all the numbers, and we are going to generate a 24 frame per second video that is called output part alternate. Yeah, so Diego, random would actually be easier. What I would recommend doing is you can do something like this. So you could do, since we're already using NumPy, we can do np.random. np.rand. Let me Google this. I never remember if it's rand or random. numpy random. Okay, so numpy random. And that's an old page. We want this one. So numpy.random will give us, so I think what we want to do is, okay, so here's what we would do. We're going to use np.randint, which returns a random integer. Remember, we want integers because they're whole numbers. And I believe we want to do 0 to 24. And I believe this is going to give us 0 to 23, but let's actually see. So usually what I'll do is test this. I'll just open up a new cell, and this is what's kind of nice about Colab is you can just add a new cell and play with it. So let's do print, and we'll do np.randint 0 to 24. Error message. NumPy has, maybe it's randint. No? Okay. Let's try this again. NumPy random integer. Of course, it's random.randint. Why would I think that you didn't need the random there? Random.randint. There you go. So if I run this over and over again, I'll get a different number every time I run it. So if you want randomness, you could just take this value and you will place this instead right here. So instead of count, actually I'm just going to add this to a new line. So body p equals body parts. And then in our brackets, we're just going to do this. So you would comment this out. Let me add this to the chat for anyone that's interested in this. This will return a random number between 0 and 23. So we don't need to worry about count or anything or calculating this. And I believe this should just always randomize. So let's take a look at this video and see what we get. So it is output part alternate. So it's kind of hard to see because it does flash so quickly, but you'll notice that there are some black screens. And when we get a black screen, that essentially means that either perhaps the mask it found, the video is all black, right? Because this one's wearing a black hood, it can be a little tricky to understand that. Or it actually doesn't find a part like that. And one of the challenges here is that if we look at our body parts array, you'll see there's a lot of back. Because our dancer never really turns her back to us, we might never find a back. So you might have to customize this array to match what you actually are looking for in the video. One of the challenges is that right now I've hard-coded in, just to throw you another little curveball. Let me comment out this random, and let me run this here. Because I've hard-coded in this 24, there's two things I can do. One is if I change this, like let's say I remove 2 of these backs. So now I have to remember to turn this into 22. The other trick would be to use a len function, which is the length, and then we go length of body parts. This says how many values are in this array, and can I just use that? So this is more, from a coding perspective, this is more future-proof because I can change the length of this, and this will always accurately return this. I didn't want to throw yet another piece of code in here for y'all, but you might see this later on because this is sort of like an easier way to sort of make sure that we're using the right length of our array here. Does that part make sense? Again, if there's any question about all of this, this is great stuff to either ask in Slack or go over in co-working. I know I'm throwing a lot at you now, and I think like what I'd love is if you say, hey, I really liked what we did here. How would I, so basically just like what Diego asked, like how could I randomize that? Or how could I maybe blur this or that sort of thing. Like if you have questions like that, please drop them in Slack or show up to a co-working session, and I'm happy to talk through that. So I'm just going to undo this just so we've got it here. Back to the basics. Yeah, cool. All right, let's look at a couple more examples or other cool things we can do with this. So we've now done a thing where like we draw just individual frames. What if I wanted this to like, what if I wanted every one of these frames, instead of just being a single frame, I wanted them to sort of stack over top of each other, right? So instead of this, what I want to do is I want to see frame 1, and then on frame 2, I want to see 2 on top of 1, 3 on top of 2 and 1, right? So we want to stack things. That's actually not that difficult to do with this setup. So again, we're going to run, I'm going to set this to be a shorter number. Let's do 40 this time, or let's do 48, so it's 2 seconds. So again, I'm going to read in my video. I'm going to create a new folder. You'll notice I'm just always creating new folders just because I don't want to overwrite previous stuff. So just remember to, if you change your name or want to play with stuff, to also update your folder name so you're not overwriting files. And then in here, I've got a couple of different arrays. I have my full body parts. I have parts that are just above the waist, and I have front parts. These are probably pretty common setups of what you're going to experience with your own videos, right? So some of you will have a video that doesn't have waist, or like it's cut off the waist, right? It's just above it's above waist and up. So this array might work better for you. In my case, I have a bunch of front parts, but no real back parts. There's a little bit of back stuff, but not too much. So maybe I just want to use this. And then I've also got one that's just hands and just faces. Hands don't work particularly well, but faces work really well. So if you want to do just faces, you can do that. One other little note here is there is this new thing, which is the previous image. You'll want to set this manually to whatever size your video is. So if your video is 640 by 40, just make sure you set this to the right value. Let's add a little note here. Set this to your video value. And I actually think this is wrong. It actually goes height first and then width. Pretty much everything in OpenCV is backwards from what you expect. So you usually think X then Y, but the way that OpenCV does it is it's H then W. I don't know why. It's some sort of legacy issue here, but this basically is, so I will say this should be height, width, and then channels. So this is usually RGB. So what is this? This is a black frame. So NP zeros, remember that 0 equals black. So it's basically creating a whole image that is all black, and it is 480 by 640 by 3. So we're going to start, we're actually, I don't even know why this is here. This is here because I need to set up a default just in case I don't want to use a frame. But the first thing we do is we overwrite that with the very first frame. So this is very complicated to say that we're going to skip this, or we're just going to replace it. So what are we going to do here? So the first thing we're going to do is we're going to loop through our video, and we're going to say if count equals 0, which is the very first frame. What we actually want to do, make the background, is actually the frame. So the very first frame of our video is going to be the background of our video. And then what we're going to do is we're going to grab our model result for that frame. We'll get the mask, and then we're going to generate parts. And here you'll see I'm pulling from the front parts value, and I'm feeding in my count, and I'm doing that modulo thing. So I'm using the length of front parts. So this is basically just saying, go in order through all of the front parts and give me all of those. We're then getting that back as a part of a mask, and then we're doing our masking using the Bitwise function. And the last thing is kind of this complicated thing where to stick an image over another image, the first thing we need to do is we need to white out the bottom, or we need to black out the bottom. So think about it almost as like if you're trying to draw over something and it's sort of semi-transparent, you want to black out the thing underneath it. So in order to do this in OpenCV, you actually need to like sort of remove everything underneath it so it's all black, and then stick the image on top of it so it like fills in that hole, almost like a puzzle piece essentially. So that's all this does. This is our create puzzle piece hole, and then paste new mask image into puzzle space. So this creates a mask for us. Then we cut out the mask and then we paste in our piece over top of it using Bitwise and. Again, I don't love doing this stuff, but it's like this is how it works in CV2. And then we can add all the pieces together. Or sorry, this is what we do. Put this down here. And then you paste in the mask on top of it. And then we're going to save that, and then we're going to save our previous result as the image. So what we're doing here is, remember, we have a previous image that we are always stacking on top of. And what we're doing is we're taking the resulted image, turning it into the previous image so that it's then usable in the next step. So this will basically create a whole stack of images for us as we begin to create masks on top of this. So let's run this. And actually, what I'm going to do, let's do this. So let's actually look at all the component parts we're building. So if I set this to 1 and I turn on these im shows here, this will show us all the parts we're using to combine. So let's run this. Okay, so this is our masked part. We're then pasting our masked part over this. Or actually what we're doing is see how this is cut out? We're taking this cutout and we're now blacking out the part where that's going to be pasted in, and then we paste it in. Now, of course, because this is the first frame, all it's doing is replacing the image. But as we go further through the stack, what we'll be doing is we'll be pasting in more. So let's take this a little bit further. Let's do this. Let's set this to 10. Run this. And as these add up, now you can sort of go through the steps and sort of see what's happening. So start all the way at the top. So here's frame 1. Here's our cutout. We've now made a gap to fit in that cut. And there it is. Now, obviously, it's just replacing it. But at frame 2, we should start to see something different. So this is frame 2. There's our mask. Here's where we're cutting it out. And here's where we're pasting it in. Now, again, because frames are not that far apart, they look kind of similar. But as we begin to build up this process more and more, and as we begin to cut out different parts, we should begin to see a little bit of changes here and there. I bet when we get to hands, here's going to be a good one. Yeah, so now you'll see the hand is offset, right? Because she's moving her hands really fast in this video. Now you'll see there's a little bit of a hand trail as we begin to do this. So let's make this a little bit longer. I'm going to comment out these things. If you leave in too many CV2 im shows, you can crash your Colab notebook because you're trying to display too many images in that frame. So let's just make this 48. We'll run this. I know we're getting close to time, so if folks need to take off, that's totally fine. I'm going to keep recording for about 15 more minutes just to finish. I've got a couple more demos I want to show. But if you need to take off, that's totally fine. And just remember, our homework is to look for a high-res image and then to watch those videos. All right, so there are all of my frames now. And I can go ahead and run this video. And I actually have a longer version of this. I have this. So this is the longer version that I ran last night. So it's kind of cool that you can it almost is like sort of chaotic. You're like seeing these like the person sort of exploding as they're moving through this. And that's just using sort of the system, right? If you were to use the random function, you might get something that's really explosive or very different. And depending on the movement, right? If someone's moving maybe fully from left to right, like if they're running across the screen, you might see something really interesting where you just see like these little like explosive pieces as they move across the screen. So there's really cool ways to play with this. And it's sort of like order of operations is really important here. And that's what matters. Any questions about that? Okay, I've got a couple more here. Okay, so this is one. Yeah, bye, Emily. Thanks for coming. We'll just have maybe 10 minutes more recording here.
I have a question.
Yeah, go for it, please.
Is there a way to knock out the background so it's on an alpha?
Mm-hmm. Yeah. So what we would do is I would actually say we would remove this line. This line just says, you know, take it the back frame. So what this will do is it'll just give us a black frame, so it'll all be on black. And you could, in a later example, I actually have it on a green screen. So if you wanted to like put it over something else, you could just green screen it out using After Effects or something. So if you remove that, you'll just get a black frame. If you keep it in, you'll get the very first frame. So here is one other example. This is a little bit different. I will probably not go through the code right now because it's a little complicated. But what this does is it actually generates a rhythm. So what it says is, and we'll cover actually more of this concept next week when we talk about music, because this will become really important to how we sequence images and sequence video to either music or to maybe create like a Rhythmic feel to our own edits and that sort of thing. So what this does is this sets up an array for how many frames of each body part we look at one at a time. So remember that we're working in 24 frames per second. So if this says 48, that means I'm asking for 48 frames, which means I'm asking for 2 seconds of a piece, right? So what this is doing is it's tying this to, which loop am I using, or what body part? So it's being tied to front parts. So what I'm saying here is I want to show for each frame, for the first 2 seconds of the video, I want to do left face. So we're going to take just the left face as we move for 2 seconds. Then we're going to take the right face for the next 2 seconds. And then we're going to do half a second on each arm part. And I believe 1 full second on the hand, 1 full second on the right hand, 2 seconds on the torso, and then again, go through each of these one by one. So this is just a fun way to start to play with, like, how do you create a little bit of a sense of movement with different pieces of the body? The code here is fairly complicated. If anyone's interested, maybe we can go through it through a co-working session, or maybe I can just record a video on how it works. But since we are getting close to time, I don't want to deal with that too much. But let me show you what this produces. So here is my draw over rhythm. Let's try this one. So it starts with just the head, and then it moves to other body parts. And again, the challenge is like with the arms, it probably isn't finding those back arms, so it just sort of skips stuff. But it does some really interesting things where it just loops through different parts of the body, or the different parts of the head. And you get sort of this nice, I think the beginning is sort of nice, where it's just fully the face. So the face is moving, and then the rest is moving, that sort of thing. You do get some nice parts when the hand, I guess it's the hand, right? Sort of like moving like this. So the last step, or the last demo, is basically taking that concept, and then I think maybe what I was mentioning in Nowco is what it does here is it actually, what does this one do? Oh, so this one is actually working on a longer video. And what this does is it actually creates sort of a decay to the rhythm. So the rhythm starts with very long sequences. So it starts with, I guess is what, 4 seconds. So it does 4 seconds, 4 seconds, 1 second, 1 second, 1 second, like whatever. And then every time it loops back to the beginning, it halves that amount. So then the next time it runs, it's 2 seconds, 2 seconds, 1 second, or half a second, half a second, half a second, half a second. Next time it gets back to that loop, it then goes 1 second, quarter of a second, quarter of a second, quarter of a second. So like we create this sort of decaying loop, so it starts out really slow, and then it gets really chaotic toward the end. Do I have an example of this? Did I save this? Where did I save this? Draw over rhythm Vogue. Let's see if this exists. Yeah. So it starts out pretty smooth, and then as the video gets longer and longer, it's probably just going to get more and more chaotic, right? Yeah, it's just going to do some really chaotic stuff. So we'll look at this a little bit more next week, because I think creating rhythm programmatically can sometimes feel weird, but like doing stuff like these decays can sort of give you that things start slow and then they get fast. And you could always do the reverse, right? Where like things start out fast and they get slow. Or you could tie them together where at some point you switch from decay to actually like multiplication. So there's a lot of different things we could do here to play with this. So that's sort of the last example I have here, which is just, being able to work with this like in time. And I found working with the Vogue video just has lots of nice faces. So I can do above the waist and just get some good poses. So I kind of think like, kind of depends on the video you're using to play with different parts of it. But there's some really nice moments in here, I think. It kind of looks like data moshing. So the last cell here in this notebook, for anyone that's interested, is I did one with green screen. So this one, the last frame, you'll see here previous image equals. And what we're using is we're actually using a rectangle function. So we're just drawing a whole rectangle that is solidly green, right? So BGR, so this is 0 blue, 255 green, and 0 red. And then we're saying fill it. And what that will do is when we produce this video, come on, buddy, you're almost done with class. So now we have a green screen. Now, I wouldn't recommend using the MP4 as your green screen. I would recommend downloading the PNGs because you won't get any compression. So your edges will be a little bit cleaner. So it's easier to green screen. But what this allows you to then do is you could then, what I actually end up doing for this is, where is this? Probably here. So I took this file into After Effects. And what I did then is I removed the green screen, placed the video underneath it, and then I believe at about 15 seconds in, it loops back again. So you'll see this head will come in right from here, and so it loops. And it doesn't really loop because the bottom doesn't loop, but it's just like you're stacking 4 videos on top of each other and using a green screen to sort of automate this. We could do this in FFmpeg. I know I've covered green screen in FFmpeg. I just find it easier to do it in After Effects than to remember the code. So even with, like, again, don't feel like you need to be beholden to just what you can produce in Colab. If you want to download the video and then bring it into Premiere or bring it into After Effects and begin to play with layering with these techniques, like that's totally valid. Like, again, this should just be a tool to play with that gets you to something new that you either make by hand or that you add to. So I thought green screen is kind of a fun effect because it gives you the opportunity to do layering with these sort of things. And you could even do shorter segments, right? This is a full minute-long video of this, but you could do 5 seconds of a clip, do a different clip, and then do a different clip, and begin to layer these things in a really interesting way. And so that is this line here. So let me just put this here. Make green screen background. Because these are PNGs, you could potentially also make them alpha channel. You could actually make it transparent. That's going to be kind of unfun with CV2 because you have to then manage a 4th channel, but you could do it. I think green screen might be easier for now. Yeah, so that's it for this class. Like I said, I'll share a couple videos that I made with this. I think the Vogue video that I did was kind of, it worked out fairly well because there's so many faces. They're just like, there's really nice face blurs and stuff in here. But yeah, think about how you might use this. And then if you have a project idea, we can talk about how to implement it a little bit more in this code. Or, you know, maybe I can help produce parts for you and then you can bring them into After Effects and generate video from that. Any questions? I threw a lot at everybody. So what I recommend doing is, would it be a complicated task to generate outlines from the mask? No, it actually isn't. I could look at how to generate code that gives us the outlines. Believe the outlines, there's actually, there's a contour function in CV2. So we could actually generate contours from our maps and then get outlines. So I'll share some code that does that. I'll make a note for myself to add to this notebook to do outlines because that's a good idea as well. Let me just add text here. Yep, I'll do that for sure. Contour, there we go. So I threw a lot at everybody. What I recommend doing is, you know, once this video is recorded or like uploaded tonight, maybe this weekend, take a little look at it. Maybe start to think about how you might utilize this. Again, we've got three other sections to talk about. So if you're not really feeling this one, maybe just wait until we talk about music stuff. Or if you have an idea for a video and you don't think you'll be using machine learning, maybe start playing with stuff and then maybe you'll get inspired as we get later through the class. But if you do have ideas, like I think the contour thing would be cool. I'm happy to just like completely add new code and things in here for people so they've got more functions to play with. If nobody has any questions, okay, so Kaimon asked about if we can get a better structured JSON. I know Ben in the Slack, I know in the Slack channel, Ben produced a slightly cleaner JSON script. If there's something in mind you have, like if you use like Touch Designer or something else and like you want the JSON structure a certain way, let me know and we can look at it. I tend to leave it just raw just so we can see what we get and then we can play with it. But like if you want the confidence values removed, we can probably do something like that. So if you have a structure in mind, just let me know what the structure is and I can probably give us some code to generate that structure. Cool. Well, I think we'll have a fun conversation next week because I think the videos we'll watch for this session will be the most fun and probably give us a lot of ideas around how to sync audio and video together. So next week we'll do like an hour of conversation for each of those videos, and then we'll do a very quick little Rhythmic demo, kind of similar to what we did here, which is like we'll take an image and we'll cut it up into a bunch of pieces, and then we'll play it back in different rhythms, which I think will be a nice introduction to sort of just creating rhythm without thinking completely about audio. And then the following week we'll actually look at how to sync audio together. All right. I will see everyone in co-working sessions or next week. Hope everybody has a good week.
Thanks, Derek.
Yep. Bye, everybody.
Thank you.
Bye, Derek. Thanks.
Yep. Bye.